Okay, last week we did, we started on EXP3A and we did 2 questions, number 1 and number 4. Did you guys try anything else? Or if you have any questions? Okay, so next let's look at, let's just do a recap question. Let's look at a question that's recap what we did, right? So number 5. Okay, so let's do this together. We have e to the power of 2x plus 5 multiply e to the power x plus 6 equals to 0. Okay, so the narrative would be if, right, if this particular function is 0, then what is the solution? Okay, if this function is 0, and the rule of the function, of course, is, from the function's perspective, this is the rule of the function, and which is, we take any input, we go through that, it produces an output, and that's how the output is produced. But this time, we want the output to be 0. Okay, so we want to decide the input that will make that output equal to 0, right? So this is the context, and this is the narrative. Okay, so with that said and done, of course, we're gonna solve this equation. Okay, so from what we have, if this is 0, right, and we factor, we have e to the power of, we will write e to the power of x squared plus 5 times e to the power x, if you wish to write it that way, even though we don't need this parentheses here, but this parentheses is necessary, plus 6 equal to 0. So we look at it in a different perspective, where we recognize, by rewriting the given equation as e to the power x to the power 2, and we recognize that this will be the same. So we can imagine these are the u. Okay, so we can do explicitly or implicitly. If we do implicitly, right? If we do it implicitly, then we would have e to the power x plus 2 multiply e to the power x plus 3. So this is the result of factoring that left-hand side of the quadratic form. So basically, we view this as u squared, and this is u, and that is u, and that is u, right? So we can do it implicitly or explicitly. So right now, I'm doing this implicitly. Okay. All right. Any questions so far? And then we can use the principle number 5, right? The product of 2 numbers is 0. And then we will get, e to the power x plus 2 equals to 0, or e to the power x plus 3 equals to 0. And in the end, e to the power x would equals to -2, or, oops, let's change the color, or e to the power x equals to -3. All right. And then from e to the power x equals to -2, what do we get for x?
No solution.
No solution, right? Because e to the power x is always positive. Very good. How about from e to the power x equals to -3?
No solution.
No solution either, right? So very good. No solution because e to the power x is larger than 0 for any real number. Okay. Now, if we look back our steps, if we look at the function, could we have solved this? Could we have an answer to this equation from another perspective? In other words, can we have a different narrative? Can we have a different way of explaining this?
Yeah, we could.
How?
Would graphing it be a thing? I don't know.
You certainly can graph it. Yes, you can graph it. Okay. What happened if you graphed it?
Oh, it wouldn't show up on the graph because it's no solution.
It should show some. It should show you some kind of graph. It should show you. You probably have to adjust your your scale or your view. Okay, so let's graph this. And I actually have never graphed this one before. Okay, so I was thinking of something else. Okay, but your answer is good. Wait. Put it in the wrong place. Okay, here. Let's graph this guy. Right? So it's a little bit hard to see. In this situation, what do we want to observe? What do we want to observe? Right? We're going to adjust the picture, right? But how do we adjust the picture? Because the equation is saying if, right? If this is a 0. So we'll be interested in where the curve intersect with x-axis, right? Because this is like to find x-intercept, right? So you would adjust your picture. So we would adjust our picture near 0. So y maybe from -1 to something, I don't need to see, y equals to 2000, 1000, maybe just 10. Let's see what happens there. Right. So that's where the picture, and you can see the picture and in the other direction to negative infinity, right? It doesn't seem to touch the x-axis. This is already an indicator. So if you want to find the crossing between the curve and x-axis, there's no crossing. There's no crossing. There's no crossing. That means that if the output equals 0, that's not going to happen, right? It will never happen because this geometrically is the curve cross. We're interested in the curve crosses with the x-axis. So from the graph, okay, so you can see that the graph of not equal to 0, this graph, okay, if you like, you can make that equals to 0. I'm sorry, not equal to 0. You can just assume that function, this is the graph, and this curve is the entire graph. Of course, it goes up And if you want to see more of it, but we don't need to see more of it, really. We really don't need to see more of it, right? We just want to see in near the x-axis, in the neighborhood of x-axis where the curve crosses. And from the graph, you can see it doesn't cross the x-axis. Okay, it doesn't cross, does not cross the x-axis. Right? And thus, there's no solution. So that's one way. That's another way to explain it. But I do have another way, which is more algebraic and related to domain and range to explain it. But this explanation requires you to be certain the picture you get, either from the calculator or from whatever sources, has to be a good one. You have to get a good picture, okay? It cannot be a partial picture. If you just show a partial picture and draw a conclusion, you're bound to be disappointed. You're bound to be disappointed. Okay, so even though, so you get, if you get a complete picture, you get this one, and you can be certain it never touches the x-axis, and then you can draw the conclusion. But I do mean to show you another way, okay? And this other way, I'm going to put it on the top. Okay, the easiest way, I would say this is the easiest way. Okay, I know a lot of you may not be quite used to these kind of narrative, right? The easiest way is to do this. I would say because e to the power x is positive for any real numbers, okay, because e to the power x is positive for any real number. So this entirety, this entire function, this guy is positive. This guy is positive. A positive number plus another positive number and then plus 6. This is going to be greater than 0, what? For any real numbers as well. Right? If this is forever positive, then you say if it's equal to 0, then you're not going to get any result, right? So there's no solution. You guys understand what I'm talking about? Right, so for any real number, this left-hand side is always a positive. A positive number will never be 0, so there's no solution. So this is the value of knowing domain and range. This is the value of knowing domain and range and apply that knowledge. Of course, in some situations, you can apply this knowledge, but you're not going to get certain, you're not going to get a definitive conclusion. Right? You're not going to get a definitive conclusion. So you have to work through the algebraic steps. You have to work through the algebraic steps. All right? Does that make sense, everybody? Does it make sense, everybody? Okay, so this is the power of knowing this fact. This fact is powerful. I have quizzed you, I think at least once, right? And that narrative, if you truly understand it and use it, you will find it very useful. Okay, you look at this term, oh, this is always a positive, and this is always a positive, and 5 times a positive number is a positive. So this whole thing is a positive. A positive plus 6 is even more positive, right? So this is a very, very powerful statement. Very, very powerful statement. Okay, so without further ado, let's look at how about number 6? E to the power x minus 12 e to the power of a negative x. minus 1 equals to 0. So once again, it's an if statement. Okay, it's an if statement. This time, if you graph it, you can certainly try graphing, right? You can, right? Why not? You guys, most of you guys have a graphing calculator. If you do have one, you can make use of it. But if you don't, I'm not saying you have to buy one. I'm not saying that. But whatever technology you have, you feel free to use them, really. And I'm not against technology at all. However, you will see that if you do the graph, there will be a crossing. There will be a crossing, but you can also tell from the picture how many crossings there are, right? And if there's a crossing, it tells you there's a solution. But the question is, how do you identify that solution precisely? Precisely is the key word here. If you identify there's a crossing, okay, for example, using graphing tools, I mean, these days in time, learning mathematics, right, it's very different from the days when I was learning mathematics. The days when I was learning mathematics, we don't have a calculator. We didn't have calculator. Okay, so we have to resort to the analytical way of doing it. But these days in time, you have technology. We have technology readily available to us at our fingertips, and it's free in many cases, right? Well, of course, if you buy a calculator, you have to pay the price. But you can get these graphs from many freewares, like Desmos and so on and so forth, right? You can get the picture. But the question is that identify that precise point is the issue. So you have to, first of all, you know how to use a graph. The graph tells us, oftentimes, if you get a complete graph, okay, if you get a complete graph, it could tell you how many solutions can be expected. But the graph oftentimes cannot give us the precise value. It's an approximation. So that's how we have to resort to the algebraic way to find the precise value. Okay, you are math professors, whether it's at El Camino College or they're in four-year schools in your UCs or CSUs, USC, whatever, any school you go to, those mathematics nerdy professors, they want to see the precise value because we don't want to see you guys have the adequate algebraic skill to work the mathematics. Okay, so but do feel free to use your technology. Okay, but you need to know how to use that technology. Okay, on basic one, we have done graph of every single one of those 22 basic simple functions. And you should know those graph by hand, and you should know them how to get them by calculator. And the domain and range will be is there for you right there. You don't even have to memorize it, but you need to know the various ways in mathematics how to express it. Right? As I said, interval notation for range in a lot of cases is good, but may not be as useful as the inequality ways of expressing range. Okay, so e to the power x is larger than 0 is one of those examples, right? So I was pushing you guys to use this, because you see its power. Okay, but anyway, without further ado, did any one of you do the graph? Right, so I'm just doing the graph. It's just really at my fingertips, right? You get this graph, and we're gonna make some adjustment. Okay, I can make it say -10, +10. But on the y direction, I'm only going to make it pretty small, just, okay. and this doesn't look like a curve, it should be a curve, I can make it, a little bit more. But the focus, this is an if statement. We want the output to be 0, right? That's the story. And here we go. And you also know that this curve is a continuous. Well, continuous is actually a concept in calculus, right? So I'm saying continuous here. It's not, I'm not going to introduce a definition of in calculus for this continuity study, but you can see this curve actually does go from negative infinity to positive infinity, right? It's in both directions. The domain is all real numbers. So in that regard, you can see there's only one crossing. There's one crossing. So you kind of, you can put that in your mind as a question mark, because you should still question, is it really one crossing? Because remember, the picture we show here, is between negative 10 to 10, negative 20 to to positive 20. So in that rectangular box, we don't know, it might be crossing somewhere else. Do you guys follow me? We're not sure yet. Okay, so do not be too certain by the picture you see. So still, when you use that picture, use a graphing tool you have, you still have to be aware about the domain and range of the function itself, as the theory dictates. For example, if you graph a sine, right, your calculator is going to give you a window. Can you say the domain is from negative 20 to positive 20? Of course not. It's the domain of sine is from negative infinity to positive infinity. It's just your graph hasn't shown the whole of it. Will that graphing tool show you the whole of it? The answer is never. They can never show the whole of it, because in today's technology, as powerful as they are, we have large data, big data. Okay, we have supercomputers. Even with these technologies, the graph can still not demonstrate negative infinity to positive infinity. No, not yet. Not as I know of. Okay, so that is theoretical part. We still have to understand. We still have to know. Do you understand what I meant? So do not be limited by that graph. The graph is a reference. It's not a certainty. Okay, so without further ado, okay, we address the goodness of using technology and the shortcomings. Okay, the shortcoming is, of course, we still don't know, right? We still don't know. But anyway, but it gave us some reference. Okay, so in this case, you cannot rely on the graph to identify. Okay, we cannot rely on the graph to identify this point. Can you tell me what number that is? What is the input for the output equals 0? We know it's there, but we don't know what is the exact value, don't we? Because this point doesn't sit on 2, doesn't sit on 3, doesn't sit on 4 precisely. It's between 1 and 2. Okay, larger than 1, smaller than 2. That's all we know. But your math professor say, hey, I want the precise value. What do? You have to do the algebra. All right, so without further ado, let's find the precise value. Okay, so the graph, okay, let me put this narrative. This graph tells that there might be one, okay, or you can say there is at least one solution. Or you can say there is a solution. there is a solution. But I cannot say there's only one solution, right? Not yet, not yet. Because we see there's only one solution. There's a solution. And that's a good enough reason for us to look further for the precise algebraic solution. Okay, so that graph tells us that. So, but we still have to find it algebraically. So what do? How do we find that solution algebraically? Anybody has any clue? How do we solve this if statement? If this is true, right? That's the crossing of the curve with x-axis. So if that is true, what algebraic procedures can we do so that we can solve the, we can find the values for x? What can we do? Anybody? What can we do? Quadratic equation, but how do you get that quadratic equation? How to get to that quadratic equation? Could you show us the manipulation? Anybody? And the principle we use, principle number 1, 2, 3, 4, 5, 6. In particular, because this is the if statement, right? So the two if statement or three if statement or the if statement related sentence structure will be useful from the mathematical principles. But the principle number 1, number 2 doesn't require you use it in if statement. You can use it anytime you want. But anyway, 6 principles, which one would be most relevant to us? You see, from the beginning of the semester, we talk about 6 principles. We talk about the 6 principles. During the semester, we use these 6 principles. And today, we're in week number 11. We're still using 6 principles. So by the time you're in calculus class, you'll still be using the 6 principles. Okay, these are the building blocks. These are the rocks of mathematics. So how did you get that quadratic equation, Cortland? I agree with you. I'm glad you saw the hint, right? At the bottom of this EXP3A. But how do you get to that? So I put this context as a think out loud. So this allows you to work on the scratch paper. Okay, so this piece of paper is my scratch paper. Okay, I'm going to scratch. Do you have your scratch paper with you? Are you ready to work with me? Are you ready to work with me? Do you have your scratch paper with you? Yeah?
Yep.
All right. So there are a number of different ways to do it. So this is e to the power x, and this is e to the power negative x. We know both are positive, right? But a positive number minus another positive number minus 1. So you don't know if the whole thing is a positive or negative. From the picture, certainly you can see sometimes it's positive, sometimes it's negative, right? So there's not much we cannot do what we did with the previous question number 5. We cannot, because you don't know the sign. The sign could be positive, negative, or 0, right? The output. Now that knowing that e to the power negative x, what is e to the power negative x? E to the power negative x. In power session, we learned that e to the power negative n, what does that equal to? It's 1 over b to the power of n, right? Yes? So now the base is e, n is x. So what would this be? E to the power of x. Okay, so if this is true, then e to the power negative x is equals to 1 over e to the power x. i.e., if you take the 12 multiplied by 1, you actually get 12 over e to the power x. And e to the power x here can be viewed as e to the power x over 1, right? So there's all these algebraic forms you can manipulate with. And if this is true, what can you do? E to the power x apparently is in the denominator. Okay, but because, okay, e to the power x e to the power x is positive for any real number, right? E to the power x is positive for any real number. Could I multiply e to the power x on both sides of the equation? Can I do that? Look at the 6 principles. Number 4. As long as c is not 0, right now it's e to the power x is larger than 0, certainly it's not 0, yes, right? Okay. So which principle are we using here? If A is the same as B, then A times C is equals to B times C, where C is not 0. Principle number 4. This is such a powerful statement. And its power is in its application. Okay. So because it is positive, so you can multiply both sides by that positive number. Oh, sorry, Mr. Minus 1. I left the 1 outside. Okay, sorry about that. Okay. And then what? And then what? Well, the right-hand side, anything times 0 is still 0, isn't it? So this side is 0. And what's the right-hand side? You take e to the power x and you multiply each term. You multiply each term by it. Right? And what happens here? And that's e to the power x squared. E to the power x and e to the power x, that's reduced. So we have subtracting 12 and minus e to the power x, because e to the power x times 1 is e to the power x equals to 0. This is the quadratic equation we end up with. Okay, and you can switch the place between negative 12 and negative e to the power x, and there you go. This is the quadratic equation. Okay, so now I'm going to give you guys a couple minutes. Okay, I'm going to put away the share. Okay, I'm going to stop the share. And you guys going to start, you're going to derive this. You don't have to use it exactly the same way I do it here. Something like that. From here, you get to this step. And then we'll get together and we do it again. Okay, I'm going to give you, how about 2 minutes? Okay, are you ready? This is not a test. This is just in-class practice, and I'm not coming to your house to check on you. And you should not feel any pressure, but you must do it for your own benefit. Okay, this is just to see if you have that algebraic skill. If you have it, great. If you don't have it, and this is a time to practice it. All right, so ready, set, go. All right, guys, how's it going? Did you do it? Can you do it? I know you can do it. I knew it. I knew you can do it, right? You just need some practice. You just need some more practice. That's all you need. You're very smart. You get it, right? So shall we do it again together? Right? Okay, so if this is true, right? Knowing e to the power x is positive, so we're going to multiply both sides by e to the power x. Multiply. So I take this and multiply with every term. Right? I multiply with every term on both sides. That's principle number 4, right? Principle number 4. And now this piece, e to the power x times e to the power x, and that's equals to e to the power x squared. You see, there's a slight difference from what I did last time, right? But it's not going to change anything. Okay, it's just a different way of expressing it. And here's e to the power x times e to the power negative x. So what will happen here is that you're going to have e to the power of x plus negative x. And that's a 0. The power is 0, right? Power e to the power 0 equals 1. Do you guys see that? So this is 0, and e to the power 0 is 1. Therefore, you get 12. Okay, and over here, minus e to the power x times 1 is just, this is just going to be minus e to the power x. And the right-hand side is 0 because anything times 0. All of this is possible, is made possible because of what? Because number 1, e to the power x is positive forever. And secondly, principle number 4. Okay, principle number 4. And then we ended up with a quadratic equation. And then you can factor, right? Can we factor, right? Implicitly or explicitly, right? So we can imagine this is a u, this is a u. So can we factor this? Well, can we factor that? What you get? U plus 4, no, u minus 4, u plus 3. Any order you want, any order you want, okay? And if you don't want to do explicitly, you can do implicitly, right? Implicitly. Implicitly. And then what you get? E to the power x minus 4 equals 0. Principle number 5. Or e to the power x plus 3 equals to 0. Right? You can see why we factor. We factor because we can use principle number 5. 6. You see, from the beginning of the semester, we're very much focused on the concept of function, the methodology, and the principles, right? So there are really not many things to remember. Everything is just logical. Two kinds of statement, right? A statement or if statement, that's all. Do you see some kind of consistency now? Absolutely, absolutely consistent. Okay, so now from e to the power x equals to 4, what do we get? E to the power x minus 4 equals 0, what do we get? Well, you're going to get e to the power x equals to 4, which is, this is the equation that looks like one of those in exp1, and then x equals what? By definition, x equals to ln4, or is 2 times ln2. Okay, because 4 is 2 squared. Okay, 4 is 2 squared. And then we use power rule. Right? Even though ln4 is a solution, but oftentimes this is preferred. You're not going to lose points because you didn't do it, or you're not going to get many points because you don't do it. Or you do it or not doing it, you're not getting or losing points very much. But knowing it, being able to do it easily, that's the key. Okay, you have that, flexibility. But anyway, from this latter equation, what do we say? What do we say? There's no solution, right? Because of what? because e to the power x is positive what? For any real number. I put these in the context of think out loud. So I will give you a version of how to show work. Okay, show work. Okay, so we pretty much have everything. So I'm just going to take these, trim some unnecessary steps, right? You don't have to show the teacher this one. Okay, you don't have to show the teacher this one. And this is optional, okay? And this step is optional. Okay. Oh, sorry, I made a mistake here. Just equal sign there. Sorry about that. Okay, I'm sorry. Okay. And I would say either one of these steps is optional. Okay, so I would say this is optional. But if you show it, it's no big deal, really. Okay, but you can make your work a little bit shorter if you just trim some of those steps that are redundant. Not really redundant. It just, I mean, it's okay, right? So in the bracket, those are optional steps. So are you guys ready to try something new? But similar. How about you guys try number 7 or 8? Okay, it's your turn. Try 7 and or 8. Your turn. Okay, I'm going to step out for a few minutes. I'll be right back. Okay, 7. How's it going? Anybody want to show your work? I would like to see your work. I would love to see your work. Okay, and there's no judgment. There's no points assigned or taken away. It's just perfect. Okay, so let me see Bailey's work, but you can submit the work for the same question, and I will be happy to go over your steps with you. Okay, so let's look at this submission from Bailey. Let's see. Thank you, Bailey, for your submission. Another one. Very good. Excellent. Cortland. So we're going to do one at a time. Let's look at Bailey's. Thank you, Cortland. Just 1 second. Okay, we're going to go over Bailey's first. And new share. Here we go. All right. Very good. Number 3, Andy. Great job. Excellent. Okay, so we have 3 submissions. Everyone could submit. Everyone could submit. Okay. And I really appreciate that. We're going to go over one at a time. So do you see this piece of work? Yes. All right. So I'm going to check. I'm going to pretend I'm grading your work, but it's not anything it's going to be recorded. I'm just check the steps. Okay. Over here, you're going to you may like to put it equal to 0 here. Okay, just to be consistent. Okay, so I'm going to use my red. So if this is equals to 0, excuse me, if this equals to 0, and that step is right, this step is right, this step is very good, okay? A lot of people making mistake like this. Okay, so let me show you the mistake. Okay, Bailey did not make that mistake, but I'm going to show you the mistake I used to see. Okay, some people will turn this minus 14 e to the power negative x, they would write it this way. They would write it as 1 over 14 e to the power x. Okay, this is one of those very typical mistakes. Okay, I'm glad he didn't do that. Okay, very good. So let's continue. O is good. And he multiplied both sides by e to the power x. Okay, very good. And times 0, still 0, no problem. And this is equal e to the power x squared minus 14 plus 5e to the power x. Very good. I think you're missing, are you missing a 0 here? Okay, so don't do that. Don't miss these things because we have a coherent sentences one after another, right? So how do we read it? If this is true, then this. 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 Okay, so this is this is the rhythm of mathematics. In the if statement setting, it is always if then, if then, if then, if then, if then, if then. Okay, we just we just save those words. We didn't write those words all the time because they're so repetitive. And the other place that you missed the equal to 0 is right here. Okay, I know you're probably in a hurry, but just don't miss those little thing. Okay, but because this will guarantee the coherence of your logical statements. Okay, if then, if then, if then, if then. Okay, so this piece, of course, has no solution. And that piece, x equals ln2. So the final solution is x equals ln2. Okay, I would say it's a very good work. Okay, and it didn't make the mistake that's a common. So there's some chat comments. No solution. We did the same one. No problem. We say the same one is great. Okay, so let's look at Cortland's work. Okay, so let's look at Cortland's work. All right, so Cortland's work, and we're going to share. Yeah. Okay, does everybody see it? I can make it just a little bit larger. Okay. So keep them on the same page. Okay. Thank you, Cortland. So right here, you can see that he multiplied both sides by e to the power x. That's good. Over here, however, okay, don't do this. Okay, you should write it this way. Okay, you should write it this way. Okay, e to the power x here. You see, you wrote it the correct way, but this will be wrong. You're gonna lose a point. You're gonna lose a point for that writing. Okay, how should you write e to the power x? You wrote it exactly right. Okay, this way. Okay, so write it this way again over here. Very good here. Very good here. I do check all these little details. I do. Okay, if otherwise, I'm not doing my job. Okay, now, do you need these parentheses? No. These parentheses actually sometimes could get you in trouble. In this case, what you need to be putting in here is going to be equals to 0 here. All right, all these are good. These are good. Okay, and factoring is good. Okay, but these are good. No solution, and that piece very good. You can see even though we have different work for the same question, but people do make like little mistake here and there. Okay, I caution you guys, do not use parentheses in the if statement. You don't need to make these connections because these connections is telling the reader this piece above is the same as the next piece. Sometimes it's true, sometimes it's not true. In your case, they are true because after you did the multiplication, this guy is still in, but these equal signs are just not necessary. Do you follow me? In some other cases, these equal sign could kill you, could get you some points lost. You could lose some points because of it, because if you put an equal sign there, you will be assessed. Okay, so when I grade your work and I see, there's an equal sign, so he meant that this guy is the same as this guy, and this guy is the same as this guy, and is the same as 0. So I'm going to have to make a connection between among all of these to decide, is that equal sign validated? Do you follow me? Do you follow me, Cortland?
Yeah.
So every symbol you put there, your reader is going to judge. We're not judging you, but we're judging your work. Okay? We are judging your work. We are assessing your work. Okay? If we don't like the word judging, okay? But we are assessing your work. So these equal signs are not necessary. So I don't put anything unnecessary here. Okay? And the other piece is it's okay, but not necessary, is this piece, subtracting 7 from both sides. You can go, I know other people like to do this, not a problem, right? I know you learned this from somewhere, from middle school or whoever. This piece, you see, I mark it correct, but I also want to tell you, it's entirely unnecessary. Your teacher doesn't need to see that. I don't want to see that. I don't need to see that. Do you follow me? I mean, I don't use the word I don't want to. I don't need to see that. Okay? And most of you teachers, they don't need to see that. Just so you can use it or not using it. But I know it's a kind of habit from a majority of our students, And so that's Cortland's work. Thank you for sharing, Cortland. I appreciate that. Okay, I hope we all learn something from this process. Okay, so so let's look at the other piece of work. Okay, so let's see who's next. That's Andy's. All right, thank you, Andy, for sharing. All right. Let's look at Andy's work. I'm going to make it just a little bit larger. Okay. You would start with equal to, you need this. Because remember, recall that when we use principle number 4, it is if A is the same as B. So you have to have that equal sign there, especially you start from there, right? We start from there. So this is the number 8, right? So he's doing number 8. Very good. And here you need a 0. Look at here. So what do you mean by this notation? What is meant by this notation, Andy? Do you mean e to the power of x squared? Is that what you meant? Or do you mean e to the power x parentheses squared? Because you didn't put parentheses, the way you write it, is being regarded as that, which is a mistake. Okay, remember last week we talked about that e to the power x squared is e to the power of x multiply x. Okay, so when you multiply e to the power x with e to the power x, you don't get e to the power x squared. You need to have a parentheses there. Do you follow me? Okay, I'm going to explain some more when we get to the next page, when we go back to our screen. Okay, so he already made a mistake here. Okay, I'm sorry. Make this a big lesson, -5. Big mistake. Okay, I'm going to explain to you a little bit more. Okay, so he continued in that mistake, missing equal sign. And these missing stuff will cost you some points. Okay, the other mistake that's being made is that if this is what you've written down, it doesn't go there. Okay, but from your work, I understand you get the general idea. But there's a lot of algebraic details that need to be reworked. Okay, and you got the factors correct. But this logical mistake is also going to cost you points because we check from step 1 doesn't get to step 2. If from step 1 doesn't get to step 2, so your mistake is here. Logically, between step 1 and step 2, that's a mistake. And from step 3 to step 4, that's a mistake because from step 3 doesn't go to step 4. From step 1 doesn't go to step 2. So you are also judged, you're also being assessed between the steps. Do you guys follow me? Right? Because we read your work logically from left to right, top to bottom. If line number 2 does not lead you to line number 3, and you claim line number 2 leads to line number 3, and there's a mistake there. Okay, and we will be assigning, taking points or giving points accordingly. So his conclusions are correct. Okay, but he has these mistakes. Okay, so he has mistake number 1, 2, 3. And mostly is focused on the notation. It's on the notation. Okay, so I want you guys to write this down, and I'm going to explain to you further after we go back to the to our original work, to our original screen. Are you ready? Did you write it down? I want you guys to write down these mistakes, okay? Mistake number 1 is from e to the power x times e to the power x. That doesn't equal to e to the power x squared. This notation, I don't know what, this notation is not clear, okay? We don't know if you meant e to the power x squared, e to the power x, or e to the power of x 2. You see the difference between these two? E to the power x squared versus e to the power x times 2. E to the power x times 2 is e to the power 2 times x. They are the same. But these two are not the same. Okay? These two are not the same. And then another logical error he made is from this step doesn't go there. Okay, so I want you guys to write it down so you understand completely what are the mistakes. Equal to 0 are missing, you're going to lose some points here. You're going to lose some points there. Because your if statement is not coherent. Okay? All right, so write it down, so don't make the same mistake. And I'm going to show you how this should be done, okay? Number 7, I think I'm not gonna do number 7 first. I'm gonna do number 8. And besides, number 7 was done very well by the two gentlemen right there. So I'm gonna just do number 8 first. Okay, but first I'm gonna point out the mistakes. Okay, so e to the power x. I'm really glad that in this process, all the common mistakes, okay, pretty much all the common mistakes have surfaced, have shown up, okay, which is very helpful for my lecture. So I really, really appreciate you guys' contribution. Okay, so let's look at Andy's work. Okay, so he multiplied both sides by e to the power x. And inside the parentheses, of course, we're gonna put it there. The narrative, right? You guys keep missing those equal sign equals 0. It is this. If this is true, okay, then that's how you read it. And then if this is true, okay, this is how mathematics is read. If this is true, and then, okay, so I'm going to write you in the full grammar of this mathematics, okay? And then I'm going to give you the shortcut version, okay? So if this is true, then this is true. And if this is true, then, right, you're going to multiply e to the power x with e to the power x. You're really doing e to the power of x multiply e to the power x plus 15 minus 8 times e to the power x. And of course, the right-hand side is 0. E to the power x, okay? Over here, I'm going to put a note here. E to the power x multiply e to the power x is e to the power of x plus x. Okay, so you can write it as e to the power of 2x. You can also write it e to the power of x times 2. Okay, this is not often written down, but if you write it as the way it's been written, if you write it this way, well, you have, even though you have your intention to write it this way, but you write it this way by mistake, they're different. They are different. Okay, so how many ways can you write this? Because let me show you what this means. Oops. This means e to the power of x times x, right? So one is x plus x, and the other one is x times x. How can they be the same? They're not the same. Okay, so when you write it, okay, any one of us, every one of us, right? The next step, you can write it as e to the power 2x. Okay, that's one way. Plus 15, right? Or you can write it as e to the power x squared. The easy fix for Andy's question, Andy's work, is just you put a parentheses. Okay, if you look at the notes you just took, you just put parentheses. That'll be good. Okay, but not this one. Not this one. Do you follow me? I tell you, in the past and the present, okay, presently, of course, I haven't given you any quiz like this to write it down. In the past, a lot of students have lost points on these steps. So that's why last week when we're talking about these, I already addressed these issues. So please don't make these mistakes. It's a tiny mistake, but it's a terrible fatal mistake. It's a terrible fatal mistake. Okay, so this is a big mistake. Do you follow me? It's okay, write it this way. It's okay, write it that way. It's even okay to write it this way. Okay, it's even okay to write it this way. It's even okay to write it this way. But this 2 cannot be on the shoulder of x squared. So you just don't give yourself that kind of chance to be assessed incorrectly. Got it? All right. So if that is true, then that is true, right? And you can continue this process, right? Then you say, if this is true, then you just, you know, switching these 2 terms. Okay, so continue on these if then, right? And then you say, if this is true, then you see there's a lot of repetition, isn't it? Yeah. So don't miss so make your sentence whole if it is a if statement. Do you follow me? Make your sentence whole. Don't drop one side. Because if you drop in one side, it's no longer meaning the same thing. It's no longer an if statement, it's a statement. Okay, so as you can see, right, from this step, it goes to this step. That's correct. Okay, it goes to this step. Okay, it goes to this step. But it doesn't go, let's use, hold on, I'm going to redo this whole thing. Okay. Okay. Sorry about that. I'm going to redo this, okay? Because and now I want you to look at the notes, the mistakes that we are addressing, okay? Because this is related to how I grade your work, how I grade your work. From this step, you can go here. That's okay. Okay, that's okay. That's okay. Okay, from that step, you can go here, and that is okay as well. Okay, from that step, you can go there, and that is okay as well. However, from this step, okay, from this step, you will see me using, when I'm grading your paper, I will use these arrows, okay? From this step to there, is that clear, everybody? It's a red, okay? That is a mistake. Do you follow me? So when I grade your work, I follow the mathematical grammar. I follow the mathematical grammar. If has to lead to then, your then must be correct. You can make whatever claim if there's a then there's something else, but these has to be correct. That's how you are being assessed. If you're missing an equal sign, that your if statement is not complete. If you're missing an equal sign in the then part, and then your statement is incomplete, right? When you write an English essay, if you have incomplete sentence, what will be the consequence? You're probably not going to get your full credit, right? Yes, I've never taught an English class, but I imagine your English teacher will require you to write complete sentences, right? Right? So don't make these mistakes. And the other thing, right? The other place I pointed out. Okay, so from here, you factored. And I pointed out this is a mistake. Right? This is a mistake. Why do I say this is a mistake? Because from here to the next step, it is not working. Because if you FOIL this latter parentheses, right? If you FOIL the latter parentheses, you're not going back to e to the power x squared. Do you follow me? So the root cause is the confusion that we pointed out here. You guys notice? I hope that is, well, I spent so much time explaining this. I hope that's enough time for you to be careful about not to make this mistake. Okay. All right. So without further ado, and of course, if then, right? So I'm gonna clean this up, because if I need to move down. Did I make myself clear? Okay. So I'm continuing this if statement, okay? So if then, and then if this is 0, then I'm quoting principle number 5. I'm quoting principle number 5. Do you follow me? So the way we write it is standard, the mathematics we write is already shorthanded. And then you drop some, you drop stuff left and right, of course, you're not gonna lose points. You're gonna lose points, okay? So now the next one, of course, and it's still then, right? And then I'm just going to say e to the power x equals to 3. I will give you a closure, okay? I will give you a closure. Okay, or e to the power x equals to 5. And of course, another if then. So it's a string of if then in mathematics. ln 3 or x equals to ln 5. Right? So you can see, if you use the full sentences of mathematics, you just keep doing if then. Too long. This is too long, right? So the actual show work part, okay? So I'm going to copy and paste this piece, and I'm going to show you what is being already trimmed. Where do I start? Hold on. There. show work. Okay, we don't use the if anymore. Okay, so if then are completely removed. Okay, this if removed, then, right? Then is removed. But then that if then is in your head, is in our mind. Okay. And over here, suppose I'm adopting just one of these steps. So a lot of these things were removed, right? You can even put some sort of something like that, okay? And bring the 15 over here. And these if then they're just gone. You see all these trimming. Do you guys see all these trimming? Okay, so the way we write mathematics is already we're already using the shortcut. Okay, we're already using the shortcut. Okay, so all these thens were gone, and that's it. Did you see how much trimming has been done already? Okay, you see how much trimming is already done. And of course, some of these steps are still optional, right? You don't have to show this step, for example, right? So this step can be optional, and so on and so forth. But anyway, without further ado, I think you guys did a really, really good job. And I especially appreciate the contribution from you guys. Okay, I think those are wonderful. And this allows me to point out the mistake you might make on the actual test or quiz ahead of the time of the quiz or exams. So on the actual test, you will not be making those mistakes, I hope. All right. So so once again, thank you so much for your contribution. Tomorrow, okay, I think you guys should be able to do all of the rest of the questions in the section EXT3A. And if you have any questions, please feel free to ask me. And tomorrow we will be heading towards the log 15A. Okay, so tomorrow we'll be heading towards the log 15A. And today, I hope that you guys will finish EXT3A for me. Okay, so wonderful job, okay? And I will see you guys tomorrow. Have a great day. It's a beautiful day today, isn't it? Is it in your part of the town? I see flowers outside. It's really nice. Okay, so enjoy your day and still do some math. I'll see you guys tomorrow.
Thank you.
Thank you, guys. Let me see what's on chat. I'm sorry if I missed anything. Okay, thank you, Cortland. Okay, thank you, Andy. Thank you, Bailey. Okay, I'll see you guys tomorrow.